So the only thing I'm going to tell you as far as how to deal with this, obviously there's two things, two rules I want you to follow. Two rules. One, I'm just going to write negative equals clockwise. Two, always measure from x-axis. Always measure your angles from the x-axis. No, but I'm just like when you're doing this, it doesn't matter what it's saying. Like, it doesn't matter if it's got y equals or whatever it equals. When you're trying to use your exact values, you need to find the key angle off your x-axis, not off your y. I'll show you what I mean. So here we've got tan 5.6. The first thing I do is I get an estimate of where I need to be. Jackson, what quadrant do you think I'll be in? First, second, third, or fourth for this question here? Sine quadrant, second quadrant, you're correct. I'm a little bit less than pi. So I look at the fraction, I don't even worry about the pi, I just look at the fraction. 5 on 6, a little bit less than 1. More than a half but less than 1. So I know I'm in this quadrant. So I draw an approximation there. Doesn't need to be perfect. This angle here is 5 pi on 6. But that's no value to me. And this is what I mean we always measure from the x-axis. The angle I want, realistically, is that one there. How big is that angle? Pi on 6. So I am pi on 6 away from the x-axis there. Happy with that? So I initially ignore the quadrant. I don't worry about it, and I do this thing called theta k. Theta k equals pi on 6, and I call that my key angle, because that's the angle I care about. So I've got x equals plus or minus tan theta k. What's the plus or minus telling me? Yeah, that will be determined by which quadrant I am in. Which quadrant am I in? So what's my value going to be? So I could straight up write negative tan theta k. Happy with that? X equals negative tan pi on 6, which equals, and then I think what's pi on 6, that's 30. I could use my exact triangles. I get negative 1 on root 3. If you got that, very well done. That's pretty much as complicated as it gets. Tan's my least favourite one to deal with because it's the one you have the least exposure to, so the one you're most likely to forget your values. Like I know off by heart that sine 30 is 1 on 2. And if you do enough examples, you'll know that. You'll know that sine 45 and cos 45 are 1 on root 2, or root 2 on 2, depending on how you like it. Cool. Next one here. What's different? What's different about it? I'll redraw my circle. It's got a 4 on the bottom, very good. It's negative, so what does that tell me? I'm going this way, okay? I'm going that way until I get a little bit past 1. Happy with that? So I draw my angle. Again, what do I care about?
Just a little.
I only care about the little bit. How much past pi is it?
1 over 5.
So pi over 4?
Yeah.
So here, I write theta k equals pi on 4. X equals positive and negative.
Negative.
It's in the sine quadrant. Negative cos pi on 4. I just said I know off by heart what pi on 4 is, which is?
45.
Negative 1 on root 2. Happy with that? Cool.
So is there ever a point where you do come off the y-axis? We learned that last. Yeah, did we learn that?
Does that make sense?
Yeah.
Do that then.
But is there a way to come off the y-axis?
Not that I can think of. Not that I'm aware of. There would be, but yeah, not in this context. That's the way to deal with it. Okay, just if that makes sense. If that makes sense, keep with that. Okay, find your key angle, measure your key angle off your x-axis. All right, the last thing I'll say, because I know the bell is looming and I know that you're short on time. One thing I want you to identify is patterns make your life a little bit easier. Sine and cos are the most frequent. I'm going to simplify this table a little bit. I'll leave that one. Let's look at tan. What do you notice about tan? Is there a pattern? Okay, root 3 is your key number. Just identify whether you're 1 on root 3 or root 3. Tan 45 is pretty obvious. It's 1. It's what 45 degrees means. You're going up as far as you're going across. Let's ignore tan for now. Do we notice a trend on those two?
They're opposite.
They're opposites, okay? So you can work backwards. If you can remember one, you know the other one. Sweet? All good. Hope that helps.